Here we have the reaction of aluminum metal and chlorine gas according to the given balanced equation. We start with 12 grams of aluminum and 42 grams of chlorine. Let's determine the limiting reactant. First, we're going to convert the mass of each reactant into moles. Starting with aluminum, we have 12 grams times 1 mole of aluminum divided by the molar mass from the periodic table, 27 grams of aluminum. That gives us 0.44 moles of aluminum. Next, 42 grams of chlorine times 1 mole chlorine. Molar mass from the periodic table is 71 grams of chlorine. And that's going to give us 0.592 moles of CO2. Now let's use the mole ratio from the balanced chemical equation to determine the amount of product, aluminum chloride, that can be made from each reactant. Starting with aluminum, we can make 2 moles of aluminum chloride from every 2 moles of aluminum. So that gives us 0.444 moles of aluminum chloride. And for the chlorine, we can make 2 moles of aluminum chloride from every 3 moles of chlorine, which gives 0.395 moles of aluminum chloride. So the reactant that produces the least amount of product will be our limiting reactant. In this case, chlorine gives us 0.395 moles of aluminum chloride, while the aluminum gives 0.44 moles. So chlorine is the limiting reactant. The theoretical yield is the maximum amount of product that can be made in grams. So in order to find the theoretical yield, we're going to take our 0.395 moles of aluminum chloride, which is the maximum amount that we can make from our limiting reactant, and convert that into grams using the molar mass from the periodic table. Which gives us 52.7 grams of aluminum chloride. If chlorine is the limiting reactant, then aluminum is in excess, and we can determine how much aluminum is left over after the reaction stops. First, we'll need to figure out how much aluminum was used to produce the 52.7 grams of aluminum chloride. So let's start with our limiting reactant. We know that we used all of our 0.592 moles of chlorine. Using the mole ratio, we can determine how many moles of aluminum were also used. We end up with 0.395 moles of aluminum used during the reaction. Since we know we started with 0.444 moles of aluminum, we can subtract the 0.395 moles that we used to tell us how much remains. And we end up with 0.0490 moles of aluminum in excess. And if we want a mass, all we need to do is convert those moles back into grams using the molar mass of aluminum. So we end up with 1.32 grams of aluminum remaining.